All right, hey everybody. So I'm here today to talk to you about evaluating limits as the function approaches infinity. So the main thing that we need to address today is when we're looking at a graph, what happens when our function is getting closer and closer to either positive or negative infinity. Fair warning, this is the first time I've had a video where my face is in it in a while, so I apologize if my face gets too close to the camera. All right, so in the past, recall that we used to call this approaching infinity or negative infinity our end behavior. All right, so sorry, end behavior. Okay, so that's when we were talking about, as x approaches infinity and y approaches and x approaches negative infinity, what was y doing, right? What was happening to y? And since our limits are our y values or our outputs, we're going to do that same thing. Now, one kind of tricky thing that you have the luxury of is I had to split my graph into graph on one side and all my problems on another side. So I'm going to be switching back and forth. You're going to be able to look at it like top and bottom of your page. So we're just going to get started by looking. It appears that questions 1, 2, and 3 all ask us to look at the limit around the number -3. So I'm going to keep that number -3 in my head and I'm going to flip back. So if I take a look at my graph right now and I go to the value of -3, -1, 2, 3, that's right here, okay? So if I look at it from the left-hand side, so this is me coming from the left, it appears we're getting closer and closer to 0. Okay, that's the height. Okay, the height that we're at is 0. 0. If I look at it from the right-hand side, so that's here, it looks like we're getting closer and closer to 6. Okay, so this was my left-hand side and my right-hand side. Okay, and just so you know, when it says left, it's going to have a negative with it. So I'm going to write a little LH under here, that's the left hand, and RH for right hand. So this one was 0, this one was 6. So then the question of, here, let me scoot my recording down a little bit for now, way down to the corner. So then the question is, what is the limit at -3? Well, the limit does not exist in this case because these two are not equal. They're not equal. The only way for the limit to exist at a specific place is for the left hand and the right hand limit to be the same. Okay? So, speaking of -3, what is the function value at -3? That's what number 4 is talking about. The function value f of -3 is actually this height right here where this dot is, which looks like it's at -4. Okay? -4. All right, so we just covered everything that's happening at -3. Now what I'd like you to do is I would like you to try the problems related. It looks like 5, 6, 7, and 8 are all related to the function value of 5. So I want you to do those problems and I'll come back and talk about those with you in just a second. Okay, folks, so if you see in blue, those are my answers for 5 through 8. Now what you might notice is that at 5, something a little bit different was happening. So you can take a moment and write those down, pause this if you need to, but I'm going to flip back to the picture and take a look at it. So here's my x value of 5, okay? And if we notice, there's this dotted line there, and that dotted line, that's your asymptote, right? So if I look at the left-hand side of that asymptote over here, the left, we are getting larger and larger as we get closer and closer to that asymptote. So we're looking at an infinity. And then if you look at the other side, sorry, I've got to scroll down a little bit so we can see that. We're going down from the right side, so that's getting closer to negative infinity, okay? Now, those two values are certainly not the same. Infinity is really, really, really big and positive, and negative infinity is really, really, really small and negative. So those are not the same. So hopefully the infinity and then negative infinity, that those two make sense. And then because they aren't the same, our limit at 5 doesn't exist. Now, the undefined is a different, you don't write does not exist there because limits, as Mean Girls tells us, limits do not exist, or there's possibility for that. But at 5, we call that value undefined. There's no definition for that value, and therefore we just say that that's undefined. Okay? So same deal, but now you're taking a look at 1. So what's happening all around, oh, I'm sorry, taking a look at what's happening all around -1. Okay? So please take a look at that value for me, and then we'll come back and check it out. All right, back again. So we're looking at -1 from the left-hand side. And if you notice in your graph, the left-hand side and the right-hand side were the exact same value around this hole in our graph. So when this happens, when our left-hand side and our right-hand side are approaching the exact same point, so they're both about to meet at the same place, that means our limit does exist at that value, and so therefore the limit is just this height of -2. Okay, so that can be really, really easy, right? -2, -2 again. All right, the limit at that number just is -2 because that's the same value. But once again, we had a hole. So a hole or a removable discontinuity or an asymptote is going to mean that the function value, its value is undefined. There's no definition for that value. Okay, just a few more for us to talk about all as a whole big group. So let's see, it looks like we've got 13 through 15 are all related to one another, all right, because those are all circulating around the number 2. So do me a favor, take a look at 2, and we'll talk about those. All right, in the home stretch now. So at 2, whether it's from the left-hand side, the right-hand side, or on both sides, you were approaching a height of 1. Okay, even though the graph comes up there and then makes this really quick turn, it's still approaching that height from both directions, and it's a solid value. So that means in addition to the limit existing there at 1, therefore on both sides, the function value f of 2 is also 1. So we've definitely seen a whole variety where the limits could have 2 different values and then a third value for the function value where they don't have the same value and then the value is undefined, where everything's the same but there's a hole, or where literally the limit from left and right is the same, so the limit's the same, so is the function value. All right, last 2 to talk about. First we've got this one. Oh wait, hang on one sec. I wanted to pick a different color. First, we've got the limit as x approaches infinity. All right, let's take a look back here. So x approaching infinity is going along the x-axis to the right-hand side. Okay, this is our infinity. Okay, so if we're going on and on and on to the right, and I'm sorry if I'm pointing the wrong way in the videos, only so, much I can do about the mirroring of things. But if you're looking at this yellow arrow, that's towards infinity. Okay, so what is my height of my function doing? This is really where we're talking about our end behavior. Okay, so how is it behaving at the end? Well, it's getting closer and closer to 0, right, in terms of the y value, okay? So that function is approaching 0. All right, the last thing to talk about is this guy right here, 18, as we approach -infinity. So same gist, but we're going to move towards the left, so -infinity. All right, so -infinity, if I look at my function here, even though there isn't an arrow, it's implied that this is just moving out of frame. So this graph is getting lower and lower. It's going to keep, if we were to extrapolate this, it's not even an extrapolation, it's a truth. It's going to keep going this way, and I know that's a little jagged. But that value is going to keep getting lower and lower and lower, right? And so what that means is we're getting more and more negative, all right? And that's going to do that for an infinite amount of time. Therefore, that function is approaching -infinity on that side. And that is its limit. And that's okay. We can have a limit be a number, we can have it be undefined, it doesn't exist, or even infinity. All right? Now, last thing before we get out of here, this graph, which should be on the very next page, has all of these problems that associate with it. So if you could go move to that next page and complete those, I will post all the answers to that in what will feel like a couple of seconds, but will take me at least a minute or 2 to write all down so that you can check those and know that you have everything all good to go. So once you've done that, you should be all set to work on your practice and homework. All right? Alright, ladies and gents, here's the last little bit of our video. So if you take a look at your whole screen, you should see all the answers to questions 1 through 15. Alright, and I've kind of color-coded them on here, and then I'm going to scroll down so you can see the answers to the last few, and if that scroll didn't give you enough time to write all those down, then you can certainly pause this so that you've got it screenshotted right there. The other thing I wanted to show you is this graph right here. So this graph I kind of have color-coded with my annotations based on each one of the questions. To me, the most interesting one out of all of those different limits is this limit at -1, because what you have, and I'll just kind of draw this over here, is you've got an asymptote, and then on the left-hand side you're going down, and on the right-hand side you're going down. So since both of those arrows are pointing in the same direction at -infinity, even though there's an asymptote there, this is still allowed to be a limit that exists. So notice -infinity, -infinity on the left, -infinity on the right, and then -infinity in general, even though the value itself is undefined at -1. All right, so I think you should be well set with limits to infinity. I hope you have an infinitely wonderful rest of your day. See ya. Bye.